you doing?
We're doing this very interesting puzzle. It's like you have a bunch of squares, and basically the numbers in the squares is the side length, and you want to figure out the side length of every other square. So let me repeat that one more time in case you didn't catch it. So as you can see right here, we have a giant rectangle. And inside the rectangle, we have divided it, the shape, into several little squares, as you can see. And a number inside a square is indicating its side length. For example, this square with the 4 inside it means its side length is 4. And in this puzzle, we are trying to figure out the side length of every single square.
That's not hard.
You think you could do it, Gimme?
Yeah.
All right.
I mean, oh god, wrong thing. Wrong color. Two. This is a 2. I'm very bad at typing 2s. Why are the boxes so tiny? There you go.
Well, it's a very small thing. Okay, Kimmy, can you tell us how you got the 2 for that?
Okay, never mind. It's actually 1. Because I found something. So if you eyeball this, there's about 9 ones to make one of the 3s. There is like about 9 ones to make one of the 3s, and then about like 25 ones to make a 4.
Okay. Well, Kimmy, you have. Okay, Eric, you have to. Okay, so Kimmy, I think you have a good starting point in that you're trying to like subtract 3 by 1, right? But um we can't quite figure out this particular square right here because we really have no clue what this one segment is, right?
Well,
So
we could just use we could just use Zoom, make a box, circle this box, copy onto this box, and it's exactly the same. That means it's 1.
well, Kimmy, they do look the same, but the thing is, what if this is like 1.1, right? We can't assume anything.
Oh.
But I am going to give you guys a hint. Consider these 2 line segments.
Oh. Oh, that. So a 3 and a 1 makes a 4. So that is a 4.
Yep, Joyce and Kimmy, you guys have both found the correct answer. Indeed.
That means if we use the same concept, this is a 4 and this is probably a 1. But this one is a 3 and a 4, which means this makes a 7. This one is 4 and a 1, which makes a 5.
Okay, Kimmy, I'm gonna pause you real quick. Kimmy, slow down. Well, yes, you got that is correct. This square right here is a 5. Everyone agrees, right? Because 4 plus 1 is a 5. But I'm not quite sure that this is a 1 and that this is a 7. I'm not really sure if that's the case, Kimmy.
No. Hey, Joyce. Joyce, how do you know this square is a 1? But we could. Oh, I see the problem.
Wait, Joyce, would you like to explain your reasoning?
For which one?
How did you, what made you conclude that this is a 1?
Because on the right side, there's the 3 box, and then there's the 1 box, and then that equals 4 box. So then if you do the same thing on the left side, then the 3 box plus the 1 box also equals to 4 box. So the small box should be 1.
Oh.
Exactly. Okay, so for anyone that didn't quite catch it,
What
it's
is Eric doing?
saying that since this is 4 and this is 3, we know the difference of it has to be 4 minus 3, which is 1, right? So, yep, Joyce, you are very correct. Kimmy, does that make sense?
Yeah, which means that is 6 instead of 7. Which means, I was thinking like we ignore this 1 for now, and then we do this 5 plus 1, which equals 6.
Well, yes, this one is definitely 6, but
And then we could go find out the rest.
well, yeah, Joyce just gave us the rest. Joyce, how did you find the 5?
Because the 4 box plus the 1 box equals 5.
All right, great. Well, it seems pretty simple. So we're gonna move on to the next one if there aren't any questions about this.
We skip on to like the 9th puzzle.
Well, this one is a little bit more challenging, so maybe we should do this one first. And if you guys really want to go harder, we can.
It is obviously more. Oh, I think I already found. Why? This
Well, guys, feel free to just annotate on a screen if you want to, but you can also tell me.
Is that a square?
That is a square indeed. Everything here is a square.
Why? That is like minimum. Like minimum. I think we should start by, because we know we have 20. Oh, I don't know where to start.
We should start with this little small square right here. It's actually pretty simple.
So. Oh, I see now. So it has to be 1 and 3. It cannot be 2 and 2 or 4 and 0.
Exactly, it's 1 and 3. But why is it 1? Why is the small square 1?
Because it's tinier than the big square, and the big square has to be. The big square can't be 1, because then what will be the? Yeah, what would be the very miniature square?
Well, that is good reasoning. However, here's also a way you can see that, because you see like this one is 17, right?
Oh, they're just 1 apart.
Exactly. So you know that it has to be 1. And indeed, the other one would be 3. So as Joyce pointed out, this one would be a 7.
Then 4 plus 7 is 11. So this one is an 11.
Great.
Oh, the next one's a bit hard.
I know. How should we find the next square? It's very interesting. Eric, you want to provide any smart insights you have for this?
So I think we should take a look at, wait, let me annotate real quick. I think we should take a look at this square. Just take a look at that square real quick.
Oh, I see what you mean now. I don't really see and I see what you mean now by looking at that square.
So like, just like in these problems, generally speaking, you just want to solve the ones that you can solve first, because the other ones will just like each time you solve one square, you are able to solve the next square and over again. So Kimmy says it is 3. So why do you think that?
So what I'm thinking is this a 3, because this box right here is a 14, which means 14 minus 7, 17 is 3. So this box has to be 3.
Oh, okay, I see. So Kimmy, you're comparing like this bottom edge with this bottom edge, huh?
Yeah.
Well, you cannot also compare it by using this edge and this edge.
Oh, yeah, you could.
But yeah, regardless, yes, it is indeed 3. All right.
Okay, now Now I'm thinking of looking at the 17.
Well, maybe we should go with Eric's excellent advice, and maybe we could solve for this one.
Oh, I see what you mean by that. Oh.
Loy
Wait.
says that it's
Hmm.
30. Huh. Loy, how come you think it's 30?
I see Lois's like plan-ish thing.
Eric, what do you think? Is it 30?
So, like the ones that we did before, we can do addition to figure it out. So, but Loy, like why do you think it's 30? Like, what is your reasoning?
Someone just erased the 30, and I don't think it's me.
Yeah, I
But
think that. Wait, Joyce, why is that? Oh, I see. Joyce got the 2 because we found the 3. 17 minus, no. 17 minus 14 is 3. And then 7. Oh.
So,
What?
so for the one, like for the big square in the top right corner, which Loy said it was 30, we could actually figure it out by using the 20 and the 20 in the top left and the 3 that we have there. And like
How's that
before,
possible?
we can add it together, right, to get 23. But that one is relatively simple, but of course, what Joyce has put is a little 2. Let me just annotate that. A little 2 over here. However, that 2, we don't know, like, there are a lot of ways to figure that out. But
the most obvious reason is like the 1 is very extremely tiny. The 3 is a little bigger than the 2, which means that box has to be 2.
So what you're saying is that if you extend this line over here, then you get to 2, right?
Yeah.
Because 3 minus 1 equals 2. That does indeed work. However, the problem with that is that you are not 100% sure that this line necessarily aligns with this line, right? It could be slightly off, right? You don't know. It could be slightly off. You're not 100% sure. Now, of course, in this case, it is true, but in order to do something like this, you have to be 100% sure. So the reason why I said that we should start with this one was because using that, we can do only addition and subtraction based on squares that are bordering each other. So for example, 12, this middle square is going to be 12, and this square is 14. So there is no dispute that this is going to be 2, because 14 minus 12 will be 2. So this square minus this square will create 2, which is this square. Does that make sense to everyone here?
Yes.
Yes.
So of course, like you can do that line method, which would usually work for something like this. But if say we had like other different lengths, like 14.1, something like that, then it would be really hard to tell whether or not these lines perfectly aligned or not, which is why I believe we should use
Just use zooms.
unambiguous.
Couldn't we just use zooms, like straight line, and just measure it?
Yeah, we could, but
yeah, Zoom says it's exactly on the line.
Yeah. So of course it is exactly on the line, but for future problems, like we should try to stick to these kinds of subtraction and direct addition kinds of.
Because it could be something like 14.000001.
Yeah. And then you wouldn't know if these lines wouldn't perfectly align. You wouldn't know if they align. So just because they look like they align doesn't necessarily mean that they do. Though in this case, of course, as mentioned before, it does. Okay, so does that make sense to everyone? So I think we should move on to 11 and 16. Oh, which were whose answers?
Mine.
Wait, okay.
Wait, are you talking about this one? We actually already solved it. Can we?
Yeah, we did already solve it, but it is relatively simple compared to the other ones where you just like do addition and addition. So I think everyone should understand that one. So Hamba, do you want to
What
move
is
on?
this?
Yeah, I think.
It's a bonus question. However, I was trying to eliminate my annotations, but I think I accidentally.
Okay, let's
Oh wait.
Hambo, what have you done?
Now
Wait,
there's
I got it.
X, Y.
All right, it's here. So, do
Okay.
you guys want to do this one, or should we move on to a slightly harder one?
Can we move on to a slightly harder one?
All right. Okay, this one is harder.
Now
So
there's
why don't we
X
do
and
this one?
Y's.
Yeah, there are variables.
And then we have now introduced the English alphabet into math.
Technically speaking, it's not really the English alphabet, it is the Greek alphabet, right? Because that's
No,
what
X is English.
Oh, X is English. I am dumb. Okay.
All right, so but speaking of the Greek alphabet, how do you guys think we could solve this one?
What I'm thinking is that I think this might not be the best idea, but I think it's this. So, never mind. I have no idea.
Oh, shoot.
Oh, I understand now. We just need to make a little bit of a distance. So X is blank plus 25, right?
Uh-huh.
Which means this huge square, this X space is probably like 16 more than 25. How did I get that? I was just guessing.
Well, Kimmy, I think you were on the right track because you said this blank space plus 25 equals X, right? Well, let's think about it like this. Something plus 25 equals X, right? So what's something in terms of X?
Oh.
It would be X minus 25, right?
Yeah, but we don't know what X is. What
Right,
would
so
be-
we know that this little box right here is actually X minus 25, right?
Yeah.
Right, so now can we use the same method to figure out this box?
Yeah, then it'd be X minus 25. X minus 25 plus something.
Well, it would be 25 minus X minus 25, right?
No.
So, well, if you guys aren't super familiar with like algebra, you could write it out, but you would get something that looks like this.
How did you get 50? Oh, I get it.
Right? Because X minus 25 is basically X minus X plus 25. And that's just 50 minus X. So we could go ahead and, I don't know, it's like, I don't want to write another small one into there. So I'm just going to label it like this. You guys not understand what it means, right?
Yes.
All right, so now we know these two squares. So can we figure out this square? The one with the question mark in it?
We could. 25
How?
plus 50 minus X.
It's 25 plus 50 minus X, right?
Yeah.
which is
25x. 25
Lloyd,
minus
you got it.
x.
75 minus x is correct.
What? Oh, I get it.
Right.
I get it now.
Yeah, because 50 plus 25, 75 minus x minus x. So wait, so can we also figure out the value of this square?
We could. It's 75x plus 50 minus x.
Would you like to do the calculation yourself, or should I do it for you?
It's 125x
125
minus
not-
x.
You're very close, Kimmy. It's not quite minus x.
Uh, I have no idea.
It's you're minusing two x's.
Minus xx.
So you could just write it like this: 105 minus 2x, right? Because you have 50 minus x and 75 minus another x, right? So you're subtracting two x's.
I think we could write that out.
Yeah, that's fair. I'll type it like this. So you have 50 minus x plus 75 minus x, which is basically 50 plus 75 minus x, which is 125 minus 2x. Just like
Which
this.
means we cannot find. Oh, we can find one more thing, I think. I think we can find one more thing. This one right here. We can find that thing. By x plus x minus 25.
That is exactly correct. Do you want to do the calculation?
That means 2x minus 25.
That is correct. All right. So we only have 4 squares left.
But we're not giving exact numbers. Are we supposed to give exact numbers?
Well, we are, but we're gonna figure out what x is in the very end.
What I'm thinking right now is if we can survive this, then we could get like this square.
Or
We
maybe
can first do this one.
I agree. That one seems easier, doesn't it?
Yeah.
All right, what do you think it is?
X 2x times 2x minus 25 plus x.
Which is 3x minus
X.
5.
Yeah.
Right, okay. Three more.
I think I have an idea. No, I didn't. I do not have any idea what to do.
How could we find the next square?
I think we can. I'm just guessing, but I think we could find that square.
Okay.
Or we could find that square. Because I think we cannot find this square.
Yeah, it doesn't seem to be an easy way of finding that square. Does anyone have any ideas?
The first time we never talked.
And now it's so quiet I can hear the crickets. Oh no, we're stuck. What do we do? Eric, do you have any helpful hints for us?
So I think you don't have to only consider the sizes of the squares. You can also consider sizes of these smaller lengths, like this one, or that's actually not it, or this one. But I think the most helpful in this case would be this little length right here. Because if you know this length, then you know this bigger length. Oh wait, no. Wait, then you know, sorry about that. Then you know this bigger length. And if you know this bigger length, then you can also figure out this length, right? Because these two lengths add together to 2x minus 25, which is this length, and these two lengths add up to this. Does that make sense? Like this length
I think
plus that length.
I have an idea now.
Mhm.
I think I have an idea. So 50 minus x minus 25 is 25 minus x, which means this angle right there is 25 minus x, which means 25 minus x is this angle, which means we'll be able to find this angle because this, so 2x minus 25x is 3x 0, I think.
Yeah, I think you're on the right track, Kimmy. Well, I think Eric's idea is very genius. And indeed, as Kimmy said, we can simply subtract 50 minus x minus 25. And I did this nice little algebra here for you. So we know that this little edge right here that Eric was talking about is equal to 75 minus 2x, right? So therefore, we can now figure out the length of this little edge. Does anyone want to volunteer to do algebra and tell us what this is?
I have no idea what algebra is.
All right, then I shall volunteer. So it is obviously 2x minus 25 minus the little edge that we just found, which is 75 minus 2x. When you do these, you really want to be careful with the signs. So you should end up getting 4x minus 100. So that's the little length right here.
Okay, and that means 125 minus 2x minus 4x minus 100.
That is very much correct. So finally, we want to find the remaining length. So we do 125 minus 2x minus the length we just found. And you should end up getting negative 6x, or actually I'm gonna write this in front. So it's gonna get, you should end up getting 225 minus 6x. And indeed, this would be the length of our third square.
Once we
All
find
right.
that, then everything's easy.
I know. So we just have 2 more squares left, and I think it's pretty easy, right?
125 minus x, 2x, plus 225 minus 6x.
All right. Are there any mental math geniuses here that want to tell me what this is? No? Okay. Well, then I'm the genius. You should get 350 minus 8x. When you do calculations like these, you should always obviously group like terms together, right? So 225 minus 6x plus 125 minus 2x. 225 plus 125 is 350. 6 plus 2 is 8. So you get 350 minus 8x. All right, finally, what is the last square?
500x.
Not quite, but you're pretty close.
I'm probably like off by like 9 x's.
It's actually 14 x's, but yeah, it's
14 x's and like 575.
okay. Right, so we end up getting this. All right, so we figured out all the lengths of this square. Now the question is, what is x?
So
X is impossible to solve.
So of course x, like, so technically speaking, when you're talking about a variable, x can literally be anything. Oh, what the? Okay. Can literally be anything from negative infinity to positive infinity. So it can literally be any number ever, like literally any number at all. But in this case, because x is actually the side length of a square. It is a physical length in like sort of in geometry. It's a physical length. And lengths cannot go below 0. Does that make sense? Lengths of a geometric object cannot go below 0. Because if you cannot have like negative length, right? That doesn't make any sense.
Yeah.
So if you cannot have negative length, then that means that x cannot, has to be more than, well, it has to be more or equal to 0, right? Does that make sense?
How can it be 0?
If it's 0, then it'll just be a single point. But
Oh.
like usually in geometry, we will just consider it to be just like larger than 0. It should be positive. Because like when a square is zeroed in sides, then it just becomes like a lot harder to deal with. But
It just becomes a point, right?
yeah, it just becomes a point. It's not really a square anymore. But we also have all of these other lengths. Wait, what was this length again?
Wait, how come all the lengths disappeared? Oh wait, I erased them. My bad.
Hambo, how could you do this? So that means that all these other lengths also have to be greater than 0. Does that make sense? This 575 minus 14x must be greater than 0. 350 minus 8x must be greater than 0. 3x minus 25 also must be greater than 0. So how do we know what x has to be for this to be greater than 0? Say, let's just do a simple one first. How do we know what does x have to be for x minus 25 to be greater than 0? X minus 25 will be
And
greater.
it has to be 26 or higher. 25 exactly or higher.
Yeah. So if it is 25 or higher, then this entire thing will be greater than 0. It will be positive. Because if it was x was say 24, 24 minus 25 is of course less than 0. If it's 26, then it would be 1, which is more than 0. So this kind of idea is pretty simple. But if we were to do this same thing for every single other one of these, then we could find what x has to be, the range of values that x could be. But just one thing, for something like 50 minus x, what does x have to be actually?
50 or bigger.
50 minus x? 50 or bigger? Well, let's see. So if x is 51, then what would this 50 minus x be?
0.
If x is 51, then 50 minus 51 is
-1.
yeah, -1. And that does not, and you cannot have -1 length for this square. Of course,
Which means it has to be bigger than 0, which has to be less than 50.
yeah, x has to be less than 50. And if you just, and in this equation, you can also just, oh wait, whoops, that's more than 50. But x has to be less than 50. So what this means is that, also another way you can solve this is just 50, and if you add x to both sides, then you get 50 minus x plus x is greater than x, which means that you get 50 is larger than x, of course. So under this situation, we can do this kind of calculation for every single other square. And for 75x, does anyone want to see what that is?
No,
75 minus x.
I want to do 575.
Okay, 575 minus 14x. So in this case, actually, I think I could do text instead. That would probably be more helpful. 575 minus 14x is greater than 0. So how do you think we can solve this?
Conclusion, x is greater than 0.
Well,
X is
I think
less than 50.
I think instead of just doing this like directly for x, we could also say 575 must be greater than 14x, right? Does that make sense? Because if 14x was greater than 575, then it would be less than 0, right?
Right. So for those of you who don't quite understand what Eric is saying is we're basically saying that since we're dealing with geometric objects, all of these side lengths have to be positive, right? Because we can't have a negative side length. Therefore, when we have a square like 50, let me change to a brighter color. Therefore, when you have a square like 50 minus x, you know that 50 minus x is positive. And in order for 50 minus x to be positive, you know that x has to be a number less than 50, right? That's how we got into the conclusion that x is less than 50. And you can do the similar thing for all of the other squares, and you can get a bunch of different restrictions. But 50 minus x turns out to be the most restrictive restriction because, for example, if you look at this one, x would be less than 75, but we already have x is less than 50. So that's not very helpful. And
X is less than 20. It's more than 20. Oh.
yeah. And if you look at all of these other ones, you would get something like x is less than or equal to like, I don't know, like 40, which is honestly not that helpful. However, something that will allow us to get the exact value of x is if we solve an equation. So,
Any
I just
equation?
deleted.
I can solve an equation. I can solve an equation called 1 plus 1.
Well, what we can do is, does everyone agree that this shape is a rectangle? Like this big shape right here?
Yes.
Okay. Well, if it's a rectangle, then we can say that these two side lengths are the same, right?
Correct.
Okay. So if these two side lengths are the same, then if we set the side lengths of these two sides equal to each other, they have to be equal, right? It has to be a true statement, right?
Yeah.
Okay, so can we tell me the side length of this side in terms of x?
925 minus 22x.
Precisely, everyone. So basically, we're trying to figure out the side length of this side right here. And since we have the side length, we simply add them up, do some quick mental math, and you get this large number. All right, can we tell me the length of this bottom side?
925 minus 22x.
Well, Kimmy, that you are correct, but it's also not quite correct because we want to find it in terms of these four squares.
So that means it's 100 and 100 minus 5x.
Well, we could simply write an equation and add this up. So if you write it out, you should get 75 plus 3x, right? Because 3x minus 25 plus x plus 25 plus 75 minus x, for simplicity, you could argue that the x's cancel out. They cancel, 25's cancel. So you have 3x plus 75.
Okay.
Okay, so now we have two different expressions for the same side length, right? We know that 75 plus 3x has to be the same number as 925 minus 22x, right? Does everyone agree? We seem a little confused.
Yes, I agree.
Right, because we know that it's a rectangle, so these two side lengths has to be equal. So 75 plus 3x has to be 925 minus 22x. So to find x, we simply solve this system. I mean, not system, we simply solve this equation. So does anyone want to take a Does anyone want to try to solve this equation? Do you want to try solving this equation? All right, we seem a little stumped, so I'm going to give you guys the solution real quick, and then we're going to go through how we solve this equation. So basically, when you solve an equation like this, you want to combine terms that are alike, right? For example, in this, we have two types of terms, right? We have constants, which are numbers like these, 925, 75, 325, 6, 125, all of these are numbers. And in algebra, they are called constants. I'm going to type it right here. And we also have this other type of term that has like x's in it, like minus 22x and 3x. These are called terms that have, variables, and 22 and 3 are called the coefficients of these terms. But regardless of their names, I think we can all agree that 75 and 925 are the same kind of terms, and 3x and negative 22x are the same kind of terms. So when you solve an equation like this, you want to combine the terms that are similar. So in order to combine the terms, you would add 22x to both sides. And you would also minus 75 from both sides, right? Because as we talked about many times in the previous classes, an equation is like a scale, right? The two quantities on the two sides of the equality symbol is like your two objects on the scale. And since they're equal, we know that when you put these two objects on the scale, they are equal, right? The scale is balanced, perfectly horizontal like this. So when you do the same thing to both sides, like adding the same quantity, such as in this case, we are adding 22x to both sides and minusing 75 on both sides. We know that when we do that, we're taking away or adding the same amount of stuff, so the scale remains balanced, right? The equation remains the same. So by adding 22x and subtracting 75, we would put the terms that are alike on the same side. So for example, on the left side, we would have 22x plus 3x, and indeed we no longer have 75 because we subtracted 75 on both sides, right? And on the right side, we no longer have the minus 22x because we added 22x. 22x minus 22x is 0, so they cancel out. Instead, we have 925 minus 75. And if you simplify it further, you would have 25x is equal to 850, which means that x is equal to 850 divided by 25, which is, I would believe, is that, which mathematical genius wants to tell me what the answer? 850 over 25.
Me.
Okay, that is correct. 34, I guess one way you could quickly calculate this is to think that 100 divided by 25 is 4, right? So since it's 800, you have 8 fours. So 4 times 8 is 32. Finally, you have two 25s equal to 50 remaining. So you add the tail end 2 and you get 34. But does how we solve the equation make sense to you guys?
Yes.
Okay, Joyce, Lloyd, does it make sense to you guys? Is it confusing anyway?
No.
Oh my god.
Okay, good. Then we solve the equation. And
Thank
indeed,
God we found
in the
X.
problem, you would have to substitute x back into every one of these squares and actually calculate the value. But for the sake of time, we're not going to do it because it's just busy work and we already know how to solve the problem. So we're going to move on to a harder one.
Please don't have X.
Well, maybe we could skip this one because it actually involves the same ideas as the previous one, except it's just really bigger numbers. So unless anyone really wants to do this, we're gonna skip it.
I hate this. Can we go to the next one?
All right.
Now there's one. I don't like this. I don't like where this is going.
You don't like where this is going?
No, next, let me tell you. The next thing there's gonna be the next one. There's gonna be the Z.
Well, yeah, it does get harder and harder. But I think we should try this one because we solved the previous one. I believe in you guys. And really, Kimmy, it's just the same ideas, right? Because
Yeah, but
instead
now we
of
have two numbers.
exactly, we're just gonna have to solve some more equations, right? What do you think, Eric?
Hmm?
I think we should tackle this puzzle.
Yeah,
I feel
it's
like we
a good
should.
puzzle.
I feel like we should have done the cup stacking.
We could do that next time. But right now, let's go on to this puzzle. All right, guys, how are we gonna solve this puzzle?
I have no idea, so I'm just gonna let the other people answer.
Joyce, Kimmy wants you to answer. What do you think? Since the anxiety of being stuck on a math problem, would you like to give any helpful hints? Eric appears to be stuck as well.
No. So I think like as mentioned before, let's just try to find the square that is the simplest. And I think the simplest square is going to be this one.
So quiet. I can hear the crickets chirping.
Are there crickets in California?
Yes.
Guys, I know it seems really complicated, but you just have to remember that X is just a
The
number,
first
right?
update that came to me is guessing. X is whatever number, Y is whatever number, and we just slowly make it.
Well, it's the same thing as the ones we already did, right? Because X is just a side length, Y is just a side length. So if these two side lengths add up to this one big side length,
That means
what
this
is
is X and Y. This is X
right?
minus Y.
Well, not quite X minus Y, but it's
X
X
plus
plus
Y.
Y. Right, right? Does anyone agree, right? It's just X plus Y. Okay. So Eric, would you like to continue with your little hints?
And now you can see that we can figure out another one of the squares, right? Just using
Oh, I
the
think I
variables.
got this.
Mhm.
I think I got this. Just asking, is this square right here,
Mhm.
2x plus y?
Yes, it is.
Kimmy, tell your classmates why it is 2x plus y, because I don't.
This one is x and y, and this one is x, which means x plus y plus x is 2x plus y.
Excellent. Right. Guys, remember, it's really just numbers, and we're really just adding side lengths. So you just add these two side lengths, and you
That's
get
so
2x
easy.
plus y.
Now I got the hang of this. Now this one is 3x plus y.
Okay.
And then the next,
Uh-oh.
hmm.
Hmm.
We could do this. We could do this square right here. before we do the other squares, because then it'll become easier. So I was thinking, so then it'd be like,
I'm not really sure. Eric, what do you think we should do right now?
So I think this length right here, which is 3x plus y, may have a relationship with this length right here. And the difference is this little, wait, what if I change the color? There we go. This little chunk right here. And does anyone think they know what this little green chunk is? Because you can see that it is indeed bordering two squares that we know the values of.
Kimmy, I pointed out the answer to you.
I don't get it.
Well, Kimmy, would you agree that this green little chunk that Eric highlighted is the difference of
Aha!
the
Think
x
that
square and the y square, right?
Now I get it. I didn't realize the green little thing is y minus x.
Excellent. Eric, you agree?
Yeah.
That means the big square right here is 3x plus y minus x.
Excellent.
Or to simplify it, 2x, I think.
All right, let's see what it simplifies to. So it's 3x plus y minus x, which simplifies to 3x plus y minus x plus x, right? Because you get rid of the parentheses, which is 4x. Indeed.
Oh, just one explanation I think is really important here is y minus x here gets turned into plus x there. So if you think about it, when you're subtracting something, if say you have like a long rod here, like this little length, then when you subtract another length, which is say y minus x, then that means that this, if say it's y minus x, then that means that this little length right here, this length in yellow, is going to be x, right? Because if you add y minus x to x, then you will get this bigger length y. And thus, when you subtract y by y minus x, then you would get x. And that is why it gets turned into minus y plus x, right?
So is this square 4x minus y?
I think that's right. Okay, we have 4 more squares left. This is exciting.
And then I think right now we should focus on this square or this square.
Yeah, or how about we focus on this square? Do you think we could find this square?
Maybe, because like we could do, because this is a 4x, and then we could do 4x minus y minus 3x. No, 4x minus y plus, no, 4x minus y plus x minus x plus y.
I think you're on the right track, Kimmy. Well, do we know this side length right here, the one that I drew a question mark for?
No, but we can do, but now we know it because it's x plus y plus y.
Right. So it's just x plus 2y.
X plus y plus x plus 2y minus 4x minus y.
Right. Okay. So What does that evaluate to, Kimmy?
I have no idea.
All right, well, I have some idea. I think it's 5x plus 3y.
Okay.
Oh wait, no, I made a giant mistake. It's not 5x plus 3y.
No, it's yeah, it is 5x plus 3x.
Nah.
Not quite. I made an algebra mistake, Kimmy. Well, when you do algebra, you have to be very careful to not make sign mistakes.
Oh,
Because
you added.
yeah, we're actually subtracting by 4x, right? So I think it would be 3y minus 3x.
Yeah, I think so too.
All right, so now we have one of the boxes. All right, so it's just 3 more boxes. What about this one?
That is way easier. Which means now this box is 4x minus y minus 3y minus 3x.
Right, so it's 4x minus y minus
That's
3y minus 3x. Do you want to tell me what that is, Kimmy?
I have actually no idea. I do not
Okay.
know that. I did not
All
learn
right.
algebra to this step. I'm only in 4th grade. I haven't learned this yet.
All right, wait, then let me explain it to you. So, I'm gonna type it like this. So we're starting with 4x minus y minus 3y minus 3x in parentheses, right?
Yeah.
So if you get rid of the parentheses, the minus 3y would still be minus 3y, but like Eric explained earlier, you would now have plus 3x instead of minus 3x, right?
Mm-hmm.
Because you're minusing a negative number, which is basically like negative gives a positive. So you're actually adding it. Then you can just group the terms that are alike together because you have 4x plus 3x. So 4 apples plus 3 apples, it's 7 apples. So you have 7x, and you're subtracting y and subtracting 3y. So if I take away 1 apple from you and then take another 3 apples from you, I actually took 4 apples from you. So that means we have 7x minus 4y.
Ah.
Yep. So
And then that means this one is 7x x minus 4y minus 3y minus 3x.
are you sure it's minus, Kimmy?
No, it's plus.
Right. Okay. So that would evaluate to 4x minus y. Does everyone agree?
Yes.
All right. So it's 4x minus y. Come on, one more square. What is the last one?
7x minus 4y plus 4y minus 7 minus y.
Right.
Which
So
is
it's going to be 11x.
and 5y.
Okay. So we got all the side lengths. Now what?
I have no idea.
Okay. Uh-oh. I just erased a bunch of stuff again.
Oh my god.
No, because I want to make it easier to see. Okay. Why do I keep erasing?
I'd be like,
All the race.
Uh-oh. Okay.
How about
Well, how could we solve this? Well, I mean, we have 2 variables, right? So I would assume that we are probably gonna need 2 equations involving x and y.
oh no, warning, it's long lettucey time now.
Okay, how about this? Let's suppose that you didn't know that this is 144. How would you find this big square here?
Uh, 11x minus 5y plus 4x minus y.
Excellent. So that would be 15x minus
15x
6y.
minus 6y.
Exactly. Okay, so can we say that we must have 15x minus 6y equals 144?
Oh, I get what you're making up here, so we can slowly test out all the ideas.
Right, so we have one equation, but we need one more. Where do you think we could get that second equation?
I think we can get that equation from the x, how to calculate the x and y.
Hmm. mean, how did we get an equation last time on the other puzzle?
Just kind of multiply this and yeah.
Remember
stuff.
how we said that since it's a rectangle, I cannot erase whatever. Since it's a rectangle, the side lengths on opposite sides has to be equal, right?
Oh, which means right now we calculate the outside of it.
Right. So maybe
Which
we
means the
could
outside is 15x. Oh wait,
could we
the
set these two side lengths equal?
yeah.
Okay. So what's the side length of the left side?
The left side is 3x plus y plus 3x plus y minus 7 minus x.
Not quite. The 3x plus y is good though, but the other square is 4x, right, Kimmy?
Oh yeah, the other square is 4x.
Okay, so it's gonna be 7x plus y, right?
Yeah.
Okay, so that's the length of the right side. Now, what's the length of the left side?
Also 7x plus y, but we could also say it is 15x plus 6y plus 11x plus 5y. I mean minus 5y.
We can also just say this, right?
26x and 11y.
Right. Okay, so now we just have to solve this massive equation.
Massive. It's really massive.
All right, so as the generous person that I am, I will simplify the second equation for you a bit before I let you solve it. So
That is not a lot of generously. Something a lot of generous means solving it without even just solving it.
okay, I mean, if everyone wants me to just solve it, I can just solve it.
Yay. That means 100. What?
Okay, so we ended up with this two equations right here. And when you have something like this, it's known as something called a system of equations in two variables, right? Because right here you have two variables, x and y, and you have two equations. So mathematicians fancily call it a system of equations. And there's usually two methods to solve a system of equations. You can usually use substitution or elimination. Substitution is when you substitute, for example, y equals 2x into another equation to eliminate one variable. But elimination is when you add up two equations to eliminate one variable. And actually, we have a perfect example of elimination. Because if you look at it, what happens if we add the two equations together?
Oh, then the 6y and 6y cancel out.
Exactly.
15x minus
Right.
4x.
Excellent.
Which
So
is 9x.
right, so if we add the two equations together, we add the left sides with the left sides and right side with the right side. So the left side is 15x minus 6y plus 6y minus 4x. As we know, the 6y minus 6y cancels out. So it ends up being 15x minus 4x, which is 11x. On the right-hand side, we have 144 plus 144, which is 288. So x is just equal to 288 divided by 11. Someone tell me what that is.
That is. I don't know.
I don't think it divides evenly.
Yeah, it does not divide evenly because 200 you cannot divide it by 11.
Uh-oh.
But 88 you can divide it by 11. So now
Well,
there's a decimal.
yeah, there is indeed a decimal. Well, I suppose we have to leave it at x equals 288 divided by 11.
Or we could use a calculator. We are in the 21st century.
Yeah, but it's a repeating decimal. It's pretty tedious.
Yeah.
So we're just gonna leave it at that. And in order to solve for y, you would simply substitute x equals 288 over 11 into one of the equations. For example, if you put it into the second equation, you would just get like 6y minus 4 times 288 over 11 equals 144. And you do some basic algebra to figure out what y is. But yeah, that's how you would solve this problem. And we have figured out x and y, so we have figured out the length of every square in this problem. Are there any questions?
Ah, so much work, so much boring. Let us see.
All right, I know there's a lot of algebra and equations
No
here. So,
question, but can we go to the bonus question?
all right,
I
if there
kinda wrote
are
this
any
already.
questions, we're gonna go to the last puzzle.
I'm bored of this unless you say that we can make like some kind of letter called Z.
All right, we have a bonus question. So how about we try this one before we leave today? This problem is very different from what we've been doing, and it's a problem involving patterns. So you want to notice the patterns and the numbers, and you want to use the pattern to figure out the question mark. So what do you think it could be?
It could be 4.
How come?
I was guessing.
How about this? Guys, what is the relationship between 5 and 40?
8.
Right, you multiply by 8. And what is the relationship between 8 and 64?
8 and 64. 8. 8 times 8 is 64.
Okay, or can we say that it is 8 squared?
Yeah.
All right, okay. What is the relationship between 63 and 7?
Nine.
Okay, it multiplies by 9. And what is the relationship between 81 and 9?
Squared.
Okay, so what's the answer?
10 squared.
Not quite.
So 4 times 4 is 16. And then no, that's I don't know.
Well, it would be 16, right? Because 4 times 4 is 16. 4 squared is 16.
Ah.
All right, that's just a little cool little puzzle to finish off this class, but that is everything we have for today. Thank you very much for coming, and let us know if you have any questions.
Bye. Thank you.
Bye. Thank you, Kimmy. Good job.
Yeah.
Thank you, Joyce. Thank you, Lloyd. Good job, guys.
Bye.
Bye, Joyce.